Okay, and as we have said, it's clear that clothes is labor intensive because we have seen that clothes uses more labor than food. Then the other is it shows that food is capital intensive relatively or as compared to clothes because food uses more capital. Okay, so you can see the ratio here, or you can just simply see from the example as we have seen previously that 2 units of capital are required to produce 1 yard of clothes, but 3 units of capital or 3 capital is required to produce 1 pound of food, which shows that food is more capital intensive as compared to clothes. Okay, so each factor is used relatively intensively in the production of a good, and each good uses a factor relatively intensively, right? Clothes uses labor intensively, while the food is using capital intensively, right? And see this production possibility frontier. We have capital used in clothes here, because as we've said, K is capital, right? And so you can say this is capital used in clothes. And on the right side, it is capital used in food, right? So the capital used, there is capital used in or capital which is required to produce clothes, and capital required to produce food must be less than the total capital, or less than or equal to the total capital we have, right? Because we can only consume what we have, right? So resources cannot exceed the supply of resources we have. Okay? So for I think some student is having a problem. So you can use the password. Okay, I think about joining. So all right, so I think we have accepted now. So as I've said, there is a total capital that is given, right? So on the example here, it says that the total capital we have at home is 3,000 units of capital and 2 hours of labor available. Okay, and this is for foreign. Okay, so we're trying to say is the total capital required to produce clothes and food together should not be greater than, or it must be less than the capital we have here, right? Because the total capital we have in home is 3,000. So capital used to produce these two should not be greater than the capital we have, right? So, or it must be less than or equal to the capital we have. The same thing is true for labor. We have required labor is 1, required labor is 2, total labor we have is 2,000. So the total labor required to produce clothes and food should be less than or equal to 2,000, right? Because that is the maximum that we have. That is what this equation is telling us. We have capital used in clothes, capital used in food should be less than or equal to the total amount of capital we have, right? Same is true for labor, right? Because we have K, we have L, right? L is labor, K is capital. So this is labor required or used in clothes, and this is labor used in food. Okay? So the labor used in clothes and labor used in food should be less than or equal to the total labor we have, which here means this should be less than 3,000 for home, and it should be less than or equal to 2,000 for home, right? Because that is the total we have for home and total we have for foreign, okay? So we can put this like this. 2 quantity of clothes, that is the first, which is capital required to produce clothes, plus the labor. I mean, the capital required to produce food is 3, right? 3 quantity of food is less than or equal to how much? We have 3,000 capital. And okay, this is one equation. Because here we have, it says we need 1 yard to produce 1 yard of clothes, we need 2 capital, and to produce 1 pound of food, we need 3 capital, right? 2 capital, 3 capital. So that is, then total capital we have is 3,000. So we can say this is 2, then quantity of C, 3 quantity of food, okay, clothes, okay, this is capital we have to produce clothes, capital we have to produce food, should be less than or equal to 3,000. Okay, that is the first equation. And the second one is labor. Okay, so how much labor do we have to, I mean, do we require to produce clothes? We require 2, and we require 1. Okay, how much maximum labor we have is 2,000, right? So this means, okay, this means 2, then quantity of labor, okay, I mean quantity of clothes, plus for food we require only 1 unit of labor. So 1 times quantity of food is QF itself, should be less than or equal to 2,000, right? Because that is the maximum we have. These are the 2 functions we have. This for capital requirement, and this is for labor requirement. Okay, so keep in mind this too. Then just give me 1 minute so somebody cannot log in. So if you cannot log in using username and password, please try using the URL. Okay. Let's continue. Then what is the slope intercept for capital and the slope intercept for labor? So the slope is easy. When you calculate for quantity of F, then you can find the slope. Okay. So for example, using for capital, the slope you can calculate here, right? So this is the equation we have for capital. Okay. So it is 2 times quantity of C plus 3 times quantity of food is less than or equal to 3,000, or you can say is equal to for the equation, right? So you can, the slope you can just compute like this: plus 3 quantity of food is equal to 3,000, right? So 3 quantity of food is equal to, that means 3,000, okay, minus Q quantity of C, right? So quantity of F is equals to, you can divide both sides by 3. So when you divide this by 3, this will cancel out. Then you divide this by 3, you can have like this 1000. This means 1000 minus 2 over 3 times quantity of C. That is the equation, right? So this is the slope, right? We have talked about this last week. So this is what we call the slope for capital, right? And how can you compute the slope for labor? We have here this equation is for labor, okay? 2 times quantity of C plus quantity of food is equal to. So this is for labor. We have 2 times quantity of C plus quantity of F is equal to 2000, okay? So we compute for quantity of F, which is equal to 2000 minus 2 times quantity of C. So this is our equation, and this is the slope for labor, right? So labor constraint is steeper than capital constraint because close is relatively labor intensive. We have already discussed about this. Close is relatively labor intensive as compared to food, right? So, computing from this, we can find endpoints, right? Endpoints for both close and food. How can we compute endpoints? We just make one of, for example, if we, when computing for endpoint of close, we take quantity of food 0 and we compute how much close we can produce, right? At the same time, when we compute for endpoint of food, we take quantity of close to 0 so that we can find how much maximum food we can produce. Okay, so don't forget these two equations here. Okay, this first one and this second one. Okay, so this one is for capital, right? Capital, and this is for labor. So because we are using now these equations to compute the capital and labor constraints of our graphs. Okay, so let's find the endpoints. Have enough capital to produce 1,500 yards of clothes, but only enough labor to produce 1,000 yards. Okay, because the total capital we have is 3,000. Okay, 3,000 divided by the capital required to produce clothes is 2, which gives us 1,500. And labor, we have total labor required. Home is 2,000, and required labor to produce clothes is 2, so we have 1,000. Okay, so with all the capital required, capital in the home, and with all the labor in the home, if we can produce only clothes, okay, we can produce 1,500 if we use all capital, and we can produce 1,000 if we use all the labor. So the same thing is true for food. If we use all the capital to produce food, we can produce 1,000. And if we use all the labor to produce food, we can produce 2,000. Okay, you can see the difference, right? If we use all the capital, only 1,000. If we use all the labor, 2,000, right? Because as we have said, it requires 1 unit of labor to produce 1 clothes, right? So 2,000. So which means now 1,000 is somewhere missing. Okay, keep in mind about this. And the other is if we use all the capital, we can produce 1,500 yards of clothes. And if we use all the labor, we can produce 1,000. Okay, which means 500 is missing somewhere because of not using all the capital or all the land only to produce clothes. Okay, so let's see the endpoints on the graph. Okay, so I will get back to this one, but let's see the production possibility fronted, then it will be clear. Okay, so I will write the equations we have. Then the equation we have is 2QC plus 3QF is equal to 3000. This is capital constraint we have, right? And we have 2QC plus QF, which is equal to 2000, and this is our labor constraint, right? So we have computed this. This is capital constraint, and this is labor constraint, right? So to compute this endpoints, first, so this is the labor constraint, right? And this is the capital constraint. Okay, so let's compute the endpoint for this one, right? So I'll use a different color. Use quantity of C or close 0. If we don't produce, or if we produce 0 quantities of close, or if we produce only food, how much food we can produce? So this will be 0, right? Because 2 times 0. So this is equal to 3QF is equal to 3000. Okay, so QF is equal to 3000 over 3, which is 1000. Okay, so if we use all our capital to produce food, we can produce 1000 1000 food here. Okay, and if we produce only clothes and 0 food, it means 2 times, okay, I mean 2QC plus 0 is equal to 3000, right? Because we said we only produce clothes now. So 2QC is equals to 3000, okay? So QC is equals to 3000 over 2, which is 1500, okay? Let me do 1500, right? So we have this one, right? If we produce 0 clothes, I mean 0 food, we produce 1500 clothes. If we produce 0 clothes, we can produce 1000 food. Okay, and let's compute for this one. If so, this is the line, right? And if we use all the labor to produce only clothes, so it means 2QC plus 0 is equal to 2000, which is like this, and QC will be equal to 2000 over 2, will to be 1000. Okay, so it is here, and okay, let me use a different color for this one. Let's use this one. Okay, and this is for labor constraint. Okay, and if we produce only food, so QC is equals to 0, so QF is equal to 2000, right? So we can produce 2000 food. So take the pink for this one, for labor constraint, okay? And the green one will be for capital constraint. Okay, so now we computed the, okay, this one. So you just substitute 0 for one and compute the other, substitute 0 for the other and compute the other. So you find the endpoints. Okay, so now after you draw this graph, okay, this is the labor constraint we have, okay, and this is here the capital constraint. Okay, so this is the capital constraint 2. The slope is 2 over 3. You know this, right? because the slope for capital constraint could be computed from 3QF is equal to 3000, okay, minus 2QC, right? So QF is equal to, okay, you divide all by 3000 over 3 minus 2 over 3 QC, right? So QF is equal to 1000 minus, okay, 2 over 3 QC. So negative 2 over 3 is the slope for the capital constraint. Now compute the same thing for this one. The slope will be negative 2. So this is the labor constraint when we use all the labor we have to produce either clothes or food. And this is the capital constraint, which means if we use all the capital we have to produce either food or clothes. Okay, so this is the production possibility frontier because we draw this like this, okay, from the labor part, and this is the point, and from this it goes down like this. So this is our production. This is the production possibility frontier for the multiple or the two-factor production model. Okay, so this is our production possibility frontier. So how much of clothes and how much of food should we produce will be determined by this point. Okay, so you go from this point to the left, you find the amount of food that we can produce. Then you go down, you find the amount of clothes you can produce. Okay, so by optimal or efficient utilization of the resource we have, we can produce 500 food items and 750 clothes or yards of clothes. That is the efficient production we can have, utilizing both capital and labor. Okay? You can see here, if we produce 2,000 food, we are not producing any clothes. This means that the labor that would have been used to produce clothes is just wasted, right? And if we produce, we can actually produce 1,500 clothes, right? But this means that we will not produce any food if we produce 1,500 quantity of clothes. And this means that the capital, because food is capital intensive, the capital that we would have used to produce food is now wasted, right? Because clothes doesn't require much capital, it requires much labor, right? So this production possibility is telling us this amount of food and this amount of clothes production is the maximum units of production that we can have utilizing both capital and labor in an efficient manner. Okay? But you can see the gap here. We should have produced, I mean, we could have produced 2,000, but we produced 1,000. We could have produced 1,500, but the difference, I mean, we should have used this, but the difference, I mean, when you use labor intensive, it is only 1,000. Okay, so there is a difference here. So from 2,000 to 1,000, from 1,500 to 1,000. Okay, so this is the amount that we are sacrificing in order to produce this amount of clothes and food at optimal utilization of capital and labor. Okay, you might have noticed something different here. The production possibility frontier for two-factor production model is curved. It doesn't look like the other production possibility frontiers we have, because in single factor production possibility frontier looks like this, right? curved. I mean, not like this, okay? So when you have a production possibility frontier like this means that the production possibility frontier doesn't have a constant slope, okay? If you see this, there is a constant slope because there is a constant increase or decrease. If you take a linear line, there is a constant slope because you can compute the constant increase or decrease, okay? But for this one, you can see it comes right this, and it's curved to the right like this, okay? So at this point, we cannot have a constant slope. This slope is different, and this slope is different, okay? So we will see how we can have a constant slope for this production, okay? So I guess this is clear. So it is simple, okay? You first try to prepare your capital constraint function, okay? So this is first you have to do. Second, prepare the labor constraint equation, okay? Once you prepare this, draw the capital constraint and the labor constraint lines. When you draw, you can identify the endpoints, right? Use 0 to 1 of the factors, I mean quantities of production, compute the other. Use 0 here, compute this one, okay? So now you identify the endpoints for both clothes and food. Then you draw the graph, right? Then second, you go to your labor constraint. You use 0 for this one, compute quantity of F. And next, use 0 for quantity of F and compute the quantity of C. Then you determine the two endpoints. Then you connect them, right? So after you connect these two lines, you identify the production possibility frontier, okay? Then from there, there is this point. So this point is a point of equilibrium where the labor constraint and the capital constraint are met. So from this point, you can identify the amount of food and the amount of clothes, okay? You just draw line down to the clothes graph and to the left to the food, then you find there. So this will be the optimal amount of food and clothes that we can produce, okay? That is pretty simple. So the good part is there are so many examples in this chapter that are not included in your book. So by the way, you can, as I've told you, you can download the book, right? Introduction, I mean, International Trade Theory and Policy from Google, and try to read that, okay? So as I've said, this offers very good examples. So same examples you can try again and again and exercise, okay? So with more than one factor of production, the opportunity cost is no longer constant, and the PPF is no longer a straight line, right? So the production possibility frontier is not a straight line as we have already computed here. And as I've said, when it is not a straight line, or it is like bent on a curve, then you cannot have a constant slope, okay? But you have to solve that because you should find the slope of the production possibility frontier graph, okay? So the opportunity cost of producing 1 yard of clothes is 2/3 an example when the economy produces a low amount of clothes and high amount of food. And so now we are talking about the slope here, right? The slopes here are the opportunity costs. So in our, I think, second chapter, we talked about this, right? The slope is the opportunity cost. So just take positive. So capital constraint is 2/3, it means that the opportunity cost of producing clothes over food is 2/3, and this is opportunity cost is 2. Okay, so when the economy produces high amount of clothes and low amount of food, the opportunity cost is high, which is 2. Okay, and when the opportunity cost is high, then you have to find ways to reduce that production, because it's better this product be produced in other parts of the world and you import this product rather than producing it yourself. Okay, because we have said that in comparative advantage we check the opportunity cost. Okay, and the opportunity, if the opportunity cost of producing a product is higher in home than it is in a foreign country, then we better import this product from a foreign country, right? So when the economy devotes more resources towards production of one good, the marginal productivity of those resources tend to be low, so that the the opportunity cost is high. Okay, and this is the second example. Okay, so I'll leave this as, okay, you exercise this as a homework. Okay, so not homework actually, then the answers are already given, then you can exercise. Okay, but simply put, as I've said, suppose it says 2 hours of labor and 2 units of capital are required to produce 1 yard of clothes, right? And it says while 1 hour of labor and 3 units of capital are required to produce 1 pound of food, right? Then United States are 2,000 labor and 3,000 capital. Compute the, for example, the capital constraint. Okay, the capital constraint equation will be equal to how much? 2 units of capital required to produce what? Clothes, right? Plus how much capital is required to produce food? 3. 3 QF will be equal to 2,000. Okay, not 2,000, 3,000. That is the capital, right? And it says the other is labor constraint. Okay, to compute the labor constraint, we have 2 hours of labor to produce clothes. Okay, plus we have here 1 units of labor to produce food. So QF is equal to 2,000. Okay, so these are the 2 equations we have. Then from this you can find the production possibility frontier graph, right? You can compute the slope, right? You can compute the opportunity cost from the slope, right? So it's not that difficult. So this is the equation. Okay, so you use this to compute the capital constraint and labor constraint. But from this also, what does QF mean? 3 QF is equal to 3,000 minus 2 QC, right? And QF is equal to 1,000 minus 2/3 QC, right? So this is for labor. Labor is QF will be equal to 2,000/2 minus 2 QC/2, which is 1, which is 1,000. QF is equals to 1,000 minus QC. Okay, because it is 2 QC. Okay. We go to the left, minus 2. Okay, not over 2, because this goes to the right, that's all, right? So that is I made a mistake here. So QF will be equal to 2,000 minus 2 QC, that's all, right? We don't have to divide by 2. So this is our equation for US labor constraint, and this is capital constraint. Okay, and you might say for in the production possibility frontier here, what I have done is I just told you to go down to this and find the quantity of clothes, go to the right and find the quantity of food, okay? But the equation that you use to compute, because you cannot just automatically know what, I mean, the point here is 500 or 600, right? Or you don't know this will be 700 or 800, okay? So the simplest equation that you can use is, you have this one for labor constraint, this two for capital constraint. Just put this two. QF is equal to, okay, 2000 minus 2 QC, okay? So 2000 minus 2 QC, and QF is equal to 1000 minus 2 over 3 QC, okay? So you can compute for QC from here, right? So take this to this side, take this side, then you can find QC. So once you find QC, for example, when you compute QC, you find 750, right? So once you find 750 as QC, then substitute 750 here. 1000 minus 2 over 3 times 750. That will give you the amount of quantity of food, right? You can substitute 750 either here or here. You will have the same answer. Minus 2 times 750. You will have the same. So QF is equal to 2000 minus 1500, right? Then QF is equal to 500. Okay, you can use the same amount here. You will find 500. Okay, because by 3 1 by 3, this is 250, right? So 1000 minus 2 times 250 is 500. Okay, so not 5. So you'll find QF is equal to 500. Okay, so whether you use the QC value here or whether you use it here, you will find the same amount of QF. Okay, so now you have three things to consider, right? First thing is you compute the equation for labor constraint and capital constraint. Okay, once you compute that with QF, what you do is you just compute for the quantity of QC and quantity of QF, okay, by just doing this. Because QF is equal to this one and this one, you compute QC, and from QC you compute QF. That will be the production possibility line, okay? So this is our QF. Then this one, okay? This is the labor constraint. This is drawn using this equation. 2QC plus 3QF is equal to 3000. This is how this is drawn, okay? Because if you produce only food, this is food, right? If you produce only food, which means quantity of clothes is equal to 0. So it means 3QF is equal to